This is Mr. Martin. This video is for Precalc Honors. This is the second video for section 3.1. We're talking about exponential functions and their graphs. And in the previous video, we just finished talking about e, and we looked at an approximation of e. So let's continue on, and graph f of x is equal to e to the x. So let's make a little table here of a few values. It is an exponential function, so we know what its general shape is going to look like. Since e is a number larger than 1, as our values of x get larger, the value of the function is going to get larger, and it's going to go up to the right. So let's make a little table here, and let's do -1, 0, 1, 2, and 3. And we can use our table feature here. Let's clear that out, and now we're going to use the e to the x key, so this is just e to the first. And let's look at our table. That should be fine. Okay, so let's change that back to auto, and let's change table start to -1, and we'll go up by 1s. That should be fine. And again, back at the table. Alright, so obviously I plugged in that equation wrong, so let's go back to y equals and change the exponent here to x. There we go. Alright, so at -1 we have about 0.37. 0, of course, we have 1. Anything raised to the 0 is 1. For 1, I have my 2.718, and we'll just approximate these on the graph. For 2, I have 7.4, and for 3, I've got 20.1, which we're not going to be able to fit, but we'll go ahead and graph some of these. So at -1, I have 0.37, so somewhere around there. 0, 1, 1, 2.78, and 3 is going to be way up there. So let's go ahead and sketch a curve through there. Again, as we go to the left, it's going to approach our x-axis, and then it's going to go up. So there's a rough sketch. We'll just pretend that it goes through all those points. Alright, so there's what e to the x looks like, and we can take a look at the graph here as well. So matches ours. Over here it's approaching the x-axis. Those values are getting very small very quickly. Alright, so using the graph of e to the x, we're going to use transformations to graph the following function, and then we'll determine the domain and the range and the horizontal asymptote. So we can see we have e to the x minus 3 minus 2. So what this minus 3 is going to do, that's going to give us a horizontal shift, and then that's going to be right 3 units, and then the minus 2 is going to be a vertical shift down 2. So basically what we're going to do is we're going to take all of our values from our previous chart. So let's go ahead and put that back in here. So we have x and y from when we graphed y equals e to the x, and we just had -1, 0, 1, and we'll stop at 2. And we had 0.37, 1, 2.71, and 7.4. So now what we're going to do is we're going to shift all of these values. So now my x, we're going to go right 3, so I'm going to add 3, so that's going to be negative 1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. So all I'm doing is I'm applying this transformation to all my original x values. Now I'm going to do the same thing with my y values, shifting down 2. That's going to be subtracting 2. So I'm going to subtract 2 from all my y values. So now I've got negative 1.63, negative 1. 1 minus 2 is negative 1. 2.71 minus 2 is going to be 0.71. And 7.4 minus 2 is 5.4. So what this negative 2 also does is it moves our asymptote from the y-axis 2 units down. So here's going to be my new asymptote. And we can go ahead and take a look at a graph over here. So that's going to be e to the x minus 3, and then minus 2. Let's take a look at the graph, and you can see it's been shifted down 2, and then it's going to start coming up there. So let's graph a few points. I have 2, negative 1.67, so somewhere around here, and then 3, negative 1, and 4.71, and 5, 5.4, so somewhere about there. And we'll go ahead and sketch in our graph. So it's going to have the same basic shape, it's just shifted a little. So again, shifted to the right 3 and down 2, but it basically has the same shape. All right, let's take a look at some applications here. So let's look at, we're going to be looking at compounding interest and continuously compounding interest. And we have these two formulas here, which may look familiar. So after t years, a balance A in an account with principal P. So this principal, this is what you start with. This is the amount you're investing, or you start with. And annual interest R, okay, and that has to be in decimal form, is given by the following formulas. So for n number of times compounding per year, we have the formula A is equal to P times the quantity 1 plus R over n raised to the nt. And for continuously compounding, we have A is equal to P times e to the RT. So n compoundings a year, for example, they may give you interest on your money twice a year, or they may give it to you monthly, so they would calculate interest monthly. For continuous compounding, they're actually giving you interest continuously. So that's kind of a strange concept, but that's essentially what they're doing. And usually, well, not usually, if you have the same amount of money and the same interest rate, you're always going to make more money with continuous compounding. So let's take a look at a few examples here. And let's also keep in mind that n equals the number of times interest is calculated per year. All right, so if it's monthly, n would be 12. If it's weekly, n would be 52. All right, so for the first example here, example 5, we have a total of $4,000 is invested at an annual interest rate of 5.25% compounded monthly. Find the balance in the account after 6 years. So I've got my principal the money I start with is $4,000. I've got my rate, and I'm going to convert that to a decimal, is 0.0525, and compounded monthly, so N is 12, and T is my time in years, is going to be 6. So I know that the amount I have after those 6 years is going to be 4,000 times 1 plus 0.0525 divided by 12 raised to the 12 times 6. And if you want to go ahead and pause the video and plug that into your calculator to make sure you're doing the calculation correctly, feel free to do that. But you should get $5,477.27. Okay, so that's compounded monthly. Let's take a look at another example, and we're going to calculate this two ways. We're going to do it quarterly, so that's 4 times a year, and we're also going to calculate it continuously. So a total of $11,500 is invested in an annual interest rate of 3%. Find the balance after 4 years if the interest is compounded A, quarterly, and B, continuously. So I've got my principal is $11,500. My rate is 0.03. My time is 4 years. And then for A, I know that N is going to be quarterly, so that's 4. So I have A is equal to 11,500 times 1 plus 0.03 divided by 4 raised to the 4 times 4, because it's quarterly and for 4 years. And the amount that you would have after 4 years would be $12,960.41. So let's do the same calculation now. For part B, we know that A is equal to P times E to the RT. So that's the same 11,500 times E raised to the 0.03 times 4. And if we substitute this in, let's just go ahead and do that calculation here. So I have 11,500 E 0.03 times 4, and now we have $12,966.21. So you can see with the continuous model, you have a little bit more money, just under $6 more, but you will get more money from continuously compounding. All right, so that'll be the end of this video. What you should do is go ahead and complete the checkup, and you can check your answers in class. Again, make sure you get any of your questions answered, and we'll see you in the next video.